to most people here as one of the IoT companies in Belgium, definitely in Flanders, if not the, at least one of the. So I think you've been building a lot of expertise and experience over the last couple of years, being the pioneer basically in this domain as well, building IoT into devices, connecting, as you say here in the slide, humans and machines. What are your experiences and what's your expectation when it comes to cybersecurity? And that's really also what we are trying to help you with. So, the floor is yours.
Thank you, Ulrich. So, to immediately answer your question, our expectations are really high. So, in a nutshell, what I will do in the coming 15 minutes, I will explain a bit what we're doing, because we are very active in. We're an IoT company, and we build solutions that affect the safety and the operational efficiency on industrial sites. So that's basically our mission. Why is that important? Because, of course, the fact that we're talking about cybersecurity closely relates to that mission. What I will do, I will briefly explain you in the full consortium what we've done in the past, what kind of solutions that we've built, a little bit under the hood also, what technology are we using, so you have a bit of a view of the challenges that we're facing. And then I think most important, I've listed three, from my point of view, very important challenges to really move towards a security by design kind of hardware model. Those challenges are threefold. They affect basically the design of the application, everything related to component sourcing and supply management, but also the manufacturing. I will focus mainly on the hardware and firmware part. I do know, and we all know, that there is also very interesting stuff to do at the backend part, software part, server side. I will not cover that, although we do include that in our product portfolio, but just basically to keep a bit focused, that's the agenda. So what we are doing, and our mantra is basically to connect humans with machines. What does that mean? We developed a couple of devices and solutions that are focusing on the one hand, and that's what you see at the left of this slide, on people. So we developed this wearable device that you can use different form factors to support, to improve the safety and security and operational efficiency of workers on site. Then we also have developed equipment to be installed on vehicles, forklift trucks in particular. And that includes an anchor that we put on these vehicles, as well as an extension, which we call the driver box. And that's pretty much a display device, also with some human interaction capabilities, which collaborates closely to the anchor. In addition, we have developed a platform. The platform is basically collecting all sorts of information that originates from the devices. We support man down, dead man switch, which is sort of a worker okay kind of functionality, fall detection, wear detection of the people wearing the devices. In case of an incident, the platform is able to send SMS text messages to a particular person. There is track and trace capabilities. We support evacuation. So as you can see on the screen, there is this toggle that you can activate to initiate an activation situation, and then all the wearables get notified, and we start tracking the position of the people wearing the devices, in particular those that did not make it to the nearest muster station. There is geofencing functionality, which gives us the ability to detect if people enter a particular region without being authorized to do so. We collect vehicle and driver statistics about how they are driving. So that's the machine part, how they are driving, how safe or dangerous they're driving, idle times, usage times, etc., etc. We have open APIs to interact with external platforms, and we collect also a bunch of data on a data lake. If the tenant, the customer, obviously is giving consent to do so, such that that can be used for historical data processing. I think most important, and that's also why we are very keen on this to participate in this initiative, is we are focusing on improving worker safety and resource optimization by adopting or implementing these use cases. So again, it's about man meets machine. What are the man-related use cases or the human-related use cases? That's personal safety. Like I said, we can detect if someone if there was a fall or a shock or a no motion, we can initiate and follow up on an evacuation scenario. We also control permissions. So if you install a device like this on a forklift truck, you can also prohibit the activation, starting the mobilization of that forklift truck if the person is not certified to do so. Geofencing is also something that we're using to prevent, again, people from entering particular regions without being certified to do so. And that's the man part. That's where we use this wearable device to cover these use cases. The machine part, I briefly explained already. We're monitoring driver behavior. We're also analyzing resource utilization. That's where this device comes into play. And then there is the bridge between the man and the machine. That's where the meat part comes in. And that's where, for instance, we implement proximity detection using the equipment that is being installed on the machine as well as on the people. That the people are wearing. So that means that in case of an impending collision situation, both the worker as well as the forklift driver get informed of this situation and they can handle properly. Also, we use this setup, that's again the proximity part, to avoid people to basically put geofences outdoors and to inform people wearing the wearables, wearing the devices, if they would enter this dangerous environment, this dangerous zone, such that they, again, can handle properly and avoid this dangerous situation. How did we do that? And I will not spend too much time, but I think it's important to understand a bit of the technology under the hood. Ultra-wideband is very key. We basically are using ultra-wideband for everything that relates to positioning. All our devices are connected via NB-IoT and Cat-M1 communication with the backend server, because we also support, for instance, over-the-air update, also something that was mentioned earlier today in this consortium presentation. Indoor localization we do based on ultra-wideband. Outdoor localization is based on GNSS data. There is an IMU, there is a battery, there is very little feedback to the user using a haptics feedback and visual feedback, and that's basically because we want to avoid inattentional blindness. There's also a button that you can push if something goes wrong, so that's basically to activate the SOS feature. The anchor that I was just mentioning, that's a device that we put on the forklift trucks, is basically adopting the same blueprint. And the technologies are also rather similar, but we extended them. So ultra-wideband still very important. GNSS is there. Communication is not just using LPWA technologies, but we're also using 2G eGPRS on this device. There is CAN communication, there is digital I/O, there is Wi-Fi. If basically we deploy this infrastructure in an environment where there is no cellular communication available, battery is the same, centering is the same, and we also can charge this device with a solar power pack. And then the driver box, that's basically a device that we can use to check or to implement access control using NFC. Also comes with a CAN. Again, ultra wideband also in this device to detect if there is a driver or to detect who's the driver basically of a vehicle. There is visual and auditive feedback, and there is also a button to do all sorts of stuff. Now, I think, and again, I wanted to bring this or share this information because it's very tightly coupled to our observations and the challenges that we faced so far to really move towards a security by design kind of industrial IoT development. And to me, the challenges, and that's also what we hope to bring to this community, the challenge is to have a very effective way to support security by design begins, of course, with the application design. Reason why I elaborated a bit on what we're doing is the applications that we have built so far and that we are currently deploying in the Middle East, in Europe, but also in the US, they really need, or at least we experience that US customers, and definitely once you start talking to the government, then the privacy and the security and the cybersecurity in general is really becoming key. And the reason, of course, and I'm kicking at an open door now, is that on the one hand, we are moving towards this digitalization era, but at the same time, by increasing this digitalization, we also increase threats. There is an impact, there could be an impact on operations if someone manages to just activate an evacuation while none have to be, while this was redundant. Also, there is obviously, in case of an evacuation, when data is getting captured, if that data would be exposed, then you reveal some of the operational insights, which is something, of course, bigger companies are very reluctant to do so. So we have experienced over the past few months, and actually years, because we have been moving towards the US, that whereas originally our focus was on cost, and that was basically the main driver, the main non-functional to take into account, that the cybersecurity challenges are also really important and should be included from the very beginning. In Europe, also open door, we also need to take into account GDPR regulations. So it's not even just about the cybersecurity, it's also about privacy, taking care about privacy, sensitive data and stuff. And that's, for instance, one of the reasons why we are not storing any PII sensitive data on any of our devices, but we keep that at the customer solutions, and we just integrate using hash keys and try to basically keep everything as decoupled as possible. Now, the main challenge that I'm facing from an application device is, on the one hand, there is this trade-off between cost and cybersecurity, and we're very keen on the cybersecurity challenges and to basically go for a cybersecurity first approach. But then again, if you want to do this and you want to do this successfully, there also should be enough components available to basically implement each of those security threats. And having just one of them is from an economic point of view, it's very difficult, because then you basically stuck to that single component with secure bootloader and stuff, and that's it. And the cost of your PCB goes through the roof. So that is one challenge that we should definitely keep into account. The second one is that, and I have a software background, so I'm sometimes, could be me, but I'm lacking a bit of a methodology also to support secure component selection procedures. What we do is very simple. We start from the critical features. We then add different functionalities. We decide on which MCU to use. And then at the end of the flow, it's all about power consumption and power management. And that's basically how we select different components. We have been working on solutions specifically tailored for US governmental services, where we simply could not do that anymore, because we really had to deal with security constraints from the very beginning. For instance, the ultra-wideband, existing ultra-wideband chip that we are using today simply was a no-go, because you can sniff what is happening on the network. And for that use case, that was simply impossible. So this was the first time that we got confronted with, okay, this is where cost and cybersecurity need to be taken into account, and we need to find a good balance and also make sure that we don't make any mistakes. And we also receive support from existing communities and stuff to ensure that our component selection procedure is also in line with the security regulations. So that's from the application design. The second challenge for us is the component sourcing and supply chain. Now, again, I think everyone in this call is aware of the actual component shortage crisis, and to deal with that, there's just two options. Or you're able to basically secure your component stock. And that's what we did for one of the devices, or you just need to get creative. For the M-Anchor, we basically have been sourcing lots of components from the spot market using brokers. Now, what's the issue and the challenge that comes with this? On the one hand, it's quality. We have been confronted with fake components. We have been using IMUs where there was an accelerometer, but not really a gyroscope in it. But second, there's also a cybersecurity challenge, because you don't have any guarantees anymore on the hardware, and if you buy a module, I mean, which chip is underneath, and the firmware features. And that basically is something that is keeping us awake at the moment, because, for instance, on the modem, it's crucial that you know which firmware is being used, but also that you can validate and verify if no one basically have been performing a DFOTA before you receive those modem modules. And by basically going to brokers and stock markets, you're under sort of a gray zone, which, by the way, we have to do, or we just put ourselves out of business. But it is something that makes things very or complicates how to still be able to avoid significant cybersecurity breaches. And on top of that, what I'm also lacking is, we're talking about vulnerability databases, but I don't really have a repo available that contains firmware vulnerabilities, and then in particular the firmware vulnerabilities that come with particular modules or devices, like my GNSS module, my ultra wideband module, my communication, my modem, etc., etc. So that's where we are currently struggling with from a component sourcing and supply chain. Now, we all know that this should be just a temporary situation, but it's still something, even if we're in this transit phase, something we believe is important to take into account, because again, it's basically sort of a conflict between the non-functionals, cybersecurity on the one hand, but you still need to make sure that you can deliver, you can manufacture your devices at a reasonable cost. So this is again a trade-off to be taken into account. And then a third challenge that we are facing, since we basically are entering the US markets, is how to make sure that you can guarantee that the device that is being assembled, so now we already passed the supply chain issues and we have all the components in stock and the EMS is doing what they're good at, but how can we certify that or ensure that the device being manufactured, being assembled, that there are no modules being swapped with tempered equivalent. Again, can be on the hardware level, can be on the firmware level. So this is definitely something to take into account. Again, we feel that there is this huge push from large multinational enterprises, but also government, and in particular US government, to really take this one into account and to give serious guarantees. And that is not just about traceability and having your EMS ISO certifications all figured out, but also geopolitics. And I think that's also something to take into account. I know it's less related to the traditional SBOM thinking, but we, for instance, have been replacing or transferring our mass production, so the manufacturing from Taiwan to Europe, simply because, again, from a security point of view, and then in particular for the US market, this was kind of a must-have just to make sure that we could guarantee or put some additional guarantees on the table about devices being genuine and not being tampered with while being assembled. So that there again, there is from my point of view, a cybersecurity challenge, because also during the manufacturing, we actually have no strict guarantees about which hardware and which firmware features are being used. Yes, we can, and we do that, of course, take samples, test them, etc., etc. But you cannot do that, or we do test the full batch, but doing a very deep inspection on which firmware is used on the modem, for instance, because that's just a binary. That is not something that we can do as a startup company ourselves, just to make sure that we can stamp this device. So these are the three challenges. Again, I'm not talking about the software part. I'm not talking about the backend kind of challenges, but from a hardware firmware point of view, it is all about manufacturing. It is about the component sourcing, and it's about the application design and making sure that also the component selection is being done in such a fashion, in such a way that it's not really ad hoc, but instead more structured, such that we can prevent also from running into big security vulnerabilities. So that's, in a nutshell, my expertise, what we've been doing, and I hope that there are some questions there. Happy to answer.
Thank you very much, Nico. Thanks for that elaborate perspective. Yeah, I think I have the first basic, simple question is: do you think that SBOMs might be able to help you with some of those challenges that you've seen, from what you know, of course, now from the SBOMs?
Yeah, I think they do, but I think it's a first step. I think we might even need to go broader, to broaden the scope. I think it would help me, because at the end of the day, what you do is you create dependencies and you model dependencies, and you basically create a glimpse on how components, the dependency between components, and you expose that information for manufacturers to take into account, which is awesome. The challenge that I see is, on the one hand, what incentive would you give to companies to basically participate to that? Because you could actually even think of like a bounty hunting game and give people a fee on when they, for instance, add an addition or detect an additional dependency that was not included in the SBOM. So that is one thing I was considering, but definitely agree with the fact that the SBOM would be a first step. Also, given that hardware and firmware dependencies also would be taken into account.
Got it. In your experience now in going to other markets around the world, specifically than the US, how do you feel that's your end users, your potential customers, are considering security, cybersecurity, and do you see a difference in them demanding? I mean, do you see a difference in types of customers that are more looking to this than others, also maybe from different parts in the world?
Absolutely. I cannot give you any names, but it is clear if you go south, if you go to the Middle East, their privacy and security is less of a concern compared to if you go to the US. So that's one observation. Second observation is that the larger scale companies, and in particular government, which absolutely is not something that should be new, but they are very strict. We are talking to a bunch of very large multinationals, and the InfoSec forms that we need to fill out are really huge. And by the way, this is not just about the device itself. It's not just about the firmware. It's also about your own internal operations, because they also care about potential security vulnerabilities that you might introduce by how you operate your business. So yes, there is, and that's what I mean. If I go back like 3-4 years in time, cost was pretty much the main driver. It had to be cheap because you have to compete with other low-cost suppliers. Right now, in particular in the business that we are active, which again, safety and security related, the impact of a breach is huge. It could basically have a huge impact on a company's operation, or it could reveal some internal information about on that company, and they are very strict on basically accepting this. For one of the projects that we've been working on, for instance, all our code has been assessed by an external, and I mean firmware code, by an external auditing company for the Department of Defense. So it's not just about filling out the form, sending it, and procurement is happy. They're really strict about this, and they want to check themselves whether you actually meet these requirements, yes or no.
Right. I think in one of the cases I've seen on the SBOMs is that they do a level of digital certification of components. So some of the challenges that you raised, how can you make sure that nobody has been tampering with the firmwares, with components that you put on there, can to some extent be monitored through it. Some other challenges that I do see is, for instance, where you were also indicating if this device needs to be somewhat implemented in an environment that you do not yet control yourself. And yeah, there's maybe also the challenge of having then an external party doing an investigation. If the code is not fully compliant, would it be sufficient that it has been, for instance, only the binaries that you can provide them, or do you really need to provide them with the source code? Because I guess that not always you will be able to, or happy to provide source code. Maybe in your case it can be, but maybe in other cases it cannot be. So how, in that case, for instance, would then the customer be acceptable to just receiving binaries, or at least the checks of the binaries?
I think the main challenge is once you actually start partnering up with other OEMs and create like a joint solution. That's where things get complicated. We as a supplier, we have no issues if the legal part is really solid. I have no issues for an external company to even scrutinize my firmware or my solutions in general. But if you start building a solution, and that's why I also like what you basically have been stating, it's not just about your own product, it's also about what you integrate from third parties. And that's the make or buy decision that we all have to make when we're developing products. That's where things get complicated, because that third party partner that you basically integrate also to increase the value of your own product, that party might not have an interest in opening up basically all this IP, even though there might be a legal framework that protects with a bailment agreement that protects that protects the auditor from or you against the auditor leaking any of the code. That is a different story. So, but then we're not really talking about the technical parts anymore. Then it's more the legal framework, which, by the way, again, could be something to include also in the SBOM way of working. Although then you're talking about different dependencies, because you're not really talking about component dependencies, but you're more talking about technology vendor dependencies and how they could be linked. Yeah,
and liabilities, of course.
Yes,
yeah.
Absolutely.
Yeah, and so final question then. Okay, you're very much up to this, which of course what we really like. The question is now, how do you see others in your environment, namely suppliers that you have to work with, partners that you have to work with? As you say, you're a supplier to somewhat a larger type of integration work or project or whatever. So how do you see your other colleagues relating to security? Are they on the same pace, or do you see that they're lagging behind?
Very good question. The partners that we are working with, and then I'm talking about ultra-wideband RTLS systems, they typically are less concerned about security because of what they offer. I mean, they're offering a tracking system. There's not much you can basically do by, for instance, hacking into an RTLS localization system. Probably there is, but the risks are much lower. But then again, for us, if I'm wearing my product hat, this is a make or buy decision. So if it turns out, for instance, for one of these projects that we're doing in the US, we need to encrypt communication over UDP, over TCP, over the network. That's something that our partner is less interested to do, because they want to have a very low latency network, because that's basically what makes, or what has an effect on the accuracy of their localization. Yeah, then you don't have that many options, or they basically support this, or you just have to do it yourselves. So the way we are not at the moment advocating the SBOM procedure towards our, in its current form, towards our partners / subcontractors, but we do take into account these decisions as part of the make or buy decision that we make basically for every new product that we develop.
Great. Nico, I'm looking forward in working together with you in developing the first use cases for the SBOMs here in Flanders.
Happy to support that. Thank you.
Sure. Thank you very much for your time and for your efforts and for your sharing your views. We're moving on to our final guest of today, and